Hello, my name is Soren Sorensen. I am a student at the University of Nevada, Reno, and I play in many cybersecurity competitions or capture the flag events. And I am really a biology student, so I'm not an authority uh, or paid in any way to do this, right? So I'm working on an assignment, and I'm inviting you to collaborate on taking this a step further. The assignment is to take an academic journal article um, and try to transform it into something that's going to have a more uh, general interest or to be um, of use to at least one subset of non-serious, non-academic consumers. So this is not professional. It's not designed to be a professional communication. I'm a hobbyist and an enthusiast and a student, and I honestly think that that's where this technology right now in this particular implementation belongs. This is we'll get into it, but the article is really um, a demonstration of the first whole system implementation designed to work with this standard, right? And the standard is called CACAO, and what it is for the exchange of playbooks. So those are designed to be like automated recipes, machine readable recipes for responding to cybersecurity attacks. There are other playbooks that are used in simple system building, orchestration, um, in kind of mainstream information technology, and this takes it a step further, and it's kind of designed to make responsive playbooks that can change your system or your environment, based on a recognized signature of a cyber threat actor's attack on your systems or your environment, so that you can adapt kind of at the speed at which automated attacks happen, right? So kind of complicated. The article is very academic, and it goes deep into some of their design choices around their knowledge management system. But from my standpoint, my interest was this was an article about cyber threat intelligence. And I'm interested in that. I'm not an expert in it. I'm not paid to do it, but it's maybe something I want to do and want to learn more about. And this article wasn't what I thought it was going to be or what I hoped it would be, but I think it is actually really useful because it is the first implementation in a free and open source way to work with this standard. And I'll try to explain some of the dynamics of people who might be trying to do this as professionals and experts, and kind of what their constraints and limitations are, and then why we might get some value out of like not misusing or abusing it, but repurposing some of the components inside their system in our capture the flag strategies and games, and maybe as a comparison against some of the systems that industry is kind of pushing on students to learn. I'm going to say just one more quick thing, if I haven't already said it, about this slide. So my first idea for how I was going to transform this text was going to be like, I'll turn it into a cartoon, I'll dramatize it a little bit, and there's kind of there's a genre out there of maybe not academics, not people who have to communicate in this particular professional way to justify maybe their research grants and funding or their institutional support for it, but in marketing. And part of what I realized is that's actually expert communication to other experts in a way that serves a commercial purpose, marketing. And then there are some kind of sarcastic, fun comics about information technology that I thought were also kind of cool and inspiring. But I also realized like illustration is beyond me. But I do think like this mug of hot chocolate is an interesting idea, and I wanted to kind of create a persona of this helpful cacao creature that would help people avoid some of the pitfalls of what the paper describes as a problem of people being bound to proprietary systems and unable to transfer information quickly about ongoing attacks or or similar. You know, like this helpful mug of chocolate could help people collaborate, right? That's the idea. And when I was designing this, I had to think a little bit about like, well, who else uses, you know, a hot beverage and this kind of cheerful kind of collaboration idea. And it took a while, but I eventually realized like 20 or so years ago, 25, 30 years ago, the Java programming language and Sun Microsystems had a commercial logo of a very stylized cup of coffee that had some steam coming out of the top, but it wasn't personified, right? It didn't have hands, it didn't smile, it didn't have eyes. So maybe my impulse to try to make this cartoon character representing the cacao standard or the cacao impulse was fed a little bit by you know, the Java programming language's attempt to make itself more marketable. It was originally called Oak, and they realized they needed to make it more fun and collaborative and not just solid and boring like Oak. So that's some of the history that occurred to me after drawing that character and some other characters, which we really won't see. I'm not an illustrator, so we're going to try a different strategy here. So I am going to refer to the actual article that I used as my inspiration to begin here, and it's called Operationalizing Cybersecurity Knowledge, Design, Implementation, and Evaluation of a Knowledge Management System for CACAO Playbooks. So again, I found this doing a keyword search for subjects that I was interested in you know, professional expert academic communication that was recent. And what I searched for was cyber threat intelligence. The meat of this article, if you search out just this particular article, are a lot of the design choices they made that relate to knowledge management systems for cacao. But it also explains kind of the context in which people came up with the cacao standard. So I'm going to go ahead and read a line or two from the abstract. So modern cybersecurity threats are growing in complexity, targeting increasingly intricate and interconnected systems. To effectively defend against these evolving threats, security teams utilize automation and orchestration to enhance response efficiency and consistency. Right? And then a few sentences later, the emerging collaborative automated course of action operations, CACAO, technical specification and standard defines a common machine processable schema for cybersecurity playbooks. Okay. So this work, right, this article, this work presents the design, development, and evaluation of a knowledge management system, KMS, for managing CACAO cybersecurity playbooks through their life cycle. The resulting implementation is released as open source, which, to the best of our knowledge, comprises the first publicly available and documented work in this domain, supporting the broader uptake of CACAO playbooks and promoting the widespread use of interoperable automation and orchestration mechanisms in cybersecurity operations. Right, so that's just from their abstract, And those were like the most easily digestible passages of their abstract that might make it interesting to other people. So it's really very dense language, especially in the abstract. But I think what they have done is novel, remarkable, worth playing with, especially because it is free and open source, right? And it's designed for collaboration. But I can understand if you don't want to read 20 pages of the specifics of what they chose to incorporate into their system. And I will highlight a couple pieces of the system that I think might be fun to play with, especially in the context of like student cybersecurity competitions. So again, this CACAO refers to a standard published by Oasis Open. And Oasis Open does a few interesting things in cybersecurity. So if you're interested in cybersecurity, you're interested in standards that are designed to be open and to inform people on teams building software that really would be collaborative, that really would hopefully be reusable and interface well with each other. The Oasis Open as a standards body is pretty focused on cybersecurity. It's not as big as like IEEE or the IETF, the people who make standards for like wireless communications, like Wi-Fi is an IEEE standard. IETF, some of the RFCs that made the internet, defined the internet protocol. Really big standards organizations. Oasis Open isn't that, but they do have a lot of very smart people working on interesting problems involving artificial intelligence, cybersecurity. If you're interested in this at all, check out Oasis Open. But this specific specification for the exchange of playbook information is a standard that is available on this website, and you can check it out. So one of the components that I think is going to be most useful, most easily exploited from the standpoint of people who want to make challenging game environments where you might be tearing down in-game systems, network nodes, virtual environments, virtual machines that might change based on how you interact with them. This seems like it might be a interesting toolkit to play around with a little bit. And I play in some games where our team is initially responding to kind of a complex set of systems that have been hacked, and there's a red team that continues to attack us as we try to restore these machines, web servers and email servers, and we score points based on whether we can get these services up and running. So using playbooks sometimes to guarantee that a service is always up and running, like as quickly as they turn it off, tear it down, we can start it back up again, right? So there's like a automation in a script that says we're going to require that this service is up and running on such and such a port, and that maybe there's an alert if the signature of the file, the program that's running, the service, the executable bit of the program changes, or the configuration scripts change in their size, then we want an alert. So these are the kinds of things that you automate, and orchestration is like having a lot of different automated things working together. So hopefully that helps begin to explain what it is they're trying to do, what orchestration looks like normally in standing up an environment. Like you might want to have your application have its mail server and its web server all running at the same time. And if they're not all running and the database isn't there, then maybe you want something to change. That'd be like normal orchestration, right? You require all these things to be up and running before you start the script that says, hey, our service is available, send money, and we'll eventually ship your items out to you, right? So you want these things to restore themselves in the course of normal failures, right? Somebody accidentally unplugged a machine, you plug it back in. This is something that runs automatically when the system boots back up. So this idea of security orchestration might be, well, we've detected a number of inbound packets on this interface that says this is likely this offensive toolkit, right? So now we need to change our environment in a way that makes this known attack less impactful to our system. So that's how you might make normal orchestration happen in a security context, right? So hopefully this playbook tooling will be useful in our in-game environments. And then kind of going back to why this article in particular was appealing to me was they advertised that the requirements for their system are really pretty lean. So they're advertising that their demonstration implementation, which isn't ready for commercial production, it's not ready for prime time, but it can run on as little as 2.75 gigabytes of RAM. So I happen to have one machine that I use in my kind of testing, playing environment, something that I'll bring with me to games to be able to play with untrustworthy software, take it apart, look at malware, whatever. It's an old machine that I picked up for like $20, and it's an old Windows 8 desktop from 2014, and it has 4 gigabytes of RAM in it. So that this fits what I can do on some of my test machines. It does seem like a low barrier to entry in that this runs on a lot of free and open source software that we're already probably familiar with, Linux, and can run on really lean hardware. So that's why I think that this might be useful for our club here at the University of Nevada, Reno, to play around with a little bit side by side in comparison with the commercial offerings that vendors are encouraging us to learn and maybe deploy in a student security operations center. This more academic demonstration of an open standard is really more appropriate for a university environment and a student club than something that would lock us into a vendor. And it might be fun to take some of these components out of it and reuse them in a way that maybe the authors didn't intend, but wouldn't stop us from doing, right? So again, the context, I think that these authors are they're all European academics. In terms of the larger context that this is all happening in, an increasing number of Europeans are skeptical of having their European business data ever reside on US cloud infrastructure or being locked into a US vendor that maybe has a backdoor from the National Security Agency, right? That's going to be a fear that some people in other countries have about US information technology, just as the United States is afraid of many software implementations and technologies that come from China, like drones, I think, have recently been banned in university studies here at the University of Nevada. campus, if they're manufactured or have software from China, they all do, right? So we're kind of in the lurch for a while until there are US drone makers that we can use in our classes for remote sensing coursework here. So people in Europe are interested in other than American technology, so open standards make a lot of sense there. So that's one of the contexts. And then I think the exchange of information that this allows for it can also maybe help people break free of the context of just where they are in a place, right? So that people need more resilient systems because they have seen cyber warfare, especially in Europe, around the Russia-Ukraine conflict. So you see the European Union is one of the funders for the authors of the article, and you see that on the SORCA webpage that was sponsored by the Dutch government in part. So that's kind of the context. There are state-backed malicious actors in cyberspace, and it's kind of up to maybe non-aligned people, individuals, clubs, working outside of those frameworks to figure out how to make our systems more resilient, regardless of what these larger actors do, whether they're criminals, whether they're it involves cyber warfare of state-based actors, etc. But because this is free and open source, and because it can run on such a small set of hardware requirements, I think there is some potential there, and it's worth playing around with a little bit if you have an interest in cyber resiliency and information about cyber threats. It's kind of a cool thing to begin to look at. It's not ready for commercial widespread deployment, but it is the first step in the right direction for making a more resilient information environment for all of us. So you're not an expert, I'm not an expert, but this is an interesting beginning. And if you're a student here and you're part of the club and you want to play with some of these components in these capture the flag competitions we get into, reach out, and we'll see if we can plug you into one of the teams or one of the upcoming competitions. All right, thank you. Bye.